All right, a couple of things I need to address. So it's really important, those of you who are at home, listen up for a few minutes. Those of you here at school, pay attention. 2 pieces of information, CCP. Next year, if you are taking CCP pre-calc with Mr. D-Lab, you have to get your folder, or not your folder, but there's like a whole CCP packet that you have to complete. It is due March 1st, which March 1st is next Saturday, so I don't know why it's due March 1st. It really means it's due next Friday. Did you guys know about that packet? Have you been working on that packet? Okay, what's up, Drew? What? You have them done? Okay, are you a sophomore or a junior? You're a sophomore. Okay, yes, go. Because the next thing applies to my juniors.
I grabbed you 2 other papers, so don't grab
All right, so as I was saying, okay, here's how you get to that if you have not gotten to that yet. Okay, you go to Lake Local Schools. You go to departments. Do you see where it says departments? And you go to counseling. And when you get to counseling, you're going to go to which one? Lake Middle High School. And then along the side, you see College Credit Plus. Guys, that's what CCP stands for. CCP, College Credit Plus. Okay? And if you click on this College Credit Plus tab, you see a whole bunch of very important things. Down here, there's the presentation. Here's the packet and forms, and there's the checklist. Those are the 2 important things. They will not extend this deadline. This is a college deadline. It is not a late deadline. So you have to apply to the college. You have to have your signature on papers. You have to have a parent signature on papers. Do not wait to get these things done. Get working on your CCP packet if you are planning to get into that class next year. Questions on this? Any questions at all? All right. Next thing, juniors, calculators. Okay, for the ACT. Juniors will be taking the ACT next week. You are allowed to use your TI 82, 83, whichever of the TI 82 or 83 that you have. You may not use a TI 89 or a TI 92, which nobody has. You guys don't have those. Okay? You may not use a brother or sister that's in calculus. You may not use their calculator that has a QWERTY keyboard on it. Okay, they check one of those out to you in calculus. If you take AP Calc, you can't use that one. It has to be the one this one, the 84 or the 83. Now, here's the really, really, really important thing. When you guys come in, a lot of times you don't have your calculator charged, and so you charge it with your computer. And I'm fine with that. You oftentimes have your computer just cracked, and you have it, and you're taking the ACT on your computer, right? You are not allowed to have your TI calculator plugged into your computer at any time during the ACT. You are not allowed to have that calculator plugged into the computer at any time during the ACT. So, all juniors need to make sure that that is fully charged before the ACT. Please charge it up before your ACT, because you will not be allowed to plug it into your computer. And you're going to want it. It has log. It has natural log. You can graph things and see where they intersect. We've taught you a lot about how to do that. Okay. Juniors, do you have any questions? Good. Any other juniors? I'm trying to think who else my juniors are in here. Any other questions for my juniors? Justin, you good?
Jill.
Olivia, Jill? Get it charged. Okay. So, homework from last night. Let's start with the first 8 were really pretty quick. You just had to rewrite them from log form to exponential form or exponential form to log form, flipping back and forth. Any questions on the first 8? Okay, how was the next 4? Evaluating the next 4. Did you guys do okay? Any of them you need me to help talk you through on the next 4? Okay, how about the next 2, 13 and 14? How did you guys do on 13 and 14? Those were our rules. You could either use your rules or reason through them. Do we have any questions on 13 and 14? Okay, how'd you guys do on 15 and 16, finding the inverse? I had one question on 15, and it was a great question, and we're going to get into this a little bit today. So once you guys switched X and Y, and then when you went to undo you had X minus 10. At one point, you had X minus 10 equals 15 to the Y. So to undo that, we would swoop. You would say log base 15 of that equals, I didn't mean to use such a big highlighter, but that's all right. So we had log base 15, and it's of all of that. So this does have to be in parentheses. Somebody asked if that had to be in parentheses, and the answer is yes. And it's going to address today a difference between going right 10 and going down 10. Okay, yeah, that does have to be in parentheses. Does anybody need me to talk through 15 or 16? You guys good on those? Were those pretty easy? It seems like 17 and 18 is where they got a little tough. Am I right? Okay, so let's talk about 17 and 18. Remember, in order to graph the logarithm, I said we're going to graph the inverse. So let's switch X and Y. And now, after you switched X and Y, we had to get Y all by itself. So we're going to swoop. When you guys swoop, you're going to say 2 to the what? 2 to the X equals what? Y plus 1. What do you do now? Subtract 1. So I have 2 to the X minus 1 equals Y. So let's go ahead and make a table of values with these numbers. So I did -2, -1, 0, 1, and 2. Let's plug -2 in. If you plug -2 in, remember that would become 1 over 2 squared, which is 1 what? What's 1 over 2 squared? 1/4. What's 1/4 minus 1? -3/4, right? Or -0.75. Now plug in -1. Or use your calculator. What's 2 to the -1? Well, it'd be 1 over 2, which is a half. What's a half minus 1? -1/2. What's 2 to the 0? What's 2 to the 0? 1. What's 1 minus 1? Okay. What's 2 to the first? 2. What's 2 minus 1? What's 2 squared? What's 4 minus 1? 3. So now, how do I graph the original problem, which was log base 2 of x plus 1? What would you guys do here? You would take all these points and what? Flip them. So I have -3/4, -2, -1/2, -1, 0, 0, 1, 1, and 3, 2. So I need to graph just the blue one. Now some of you guys got to think about what the shape of this should look like. You guys had some crazy things here. So I'm going over -3/4 down -2. Over -1/2 down 1, 0, 0, 1, 1, over 3, up 2. Now, let's think about this. We said that a logarithm has an asymptote at what? The y-axis. Well, which way was this shifted? We're going to talk about this today. Which way did this get shifted? So my vertical asymptote got shifted left 1. So it was at the y-axis. My asymptote is now here. And you can see, here's my graph. Now we're going to talk more about those shifts today. Good problem. Good problem. Number 18. Okay. Let's look at the inverse of this guy. Switch X and Y. What do you guys have to do first? Swoop. Okay, so when you swoop, you get 1/2 to the X equals what? Oh, no, not first. What are you guys going to do first? Can't swoop yet. Have to add 4 first. Okay, now can we swoop? So now when you guys swoop, you're going to have what? 1/2 to the what? X plus 4 equals Y. So now we're going to make a table of values for that. -2, -1, 0, 1, and 2. All right, I'm going to start with my positive values. So plug in 2. What's 2 squared? 4, okay. And then, no, you answered me perfect. Plug in 2. What's 2 plus 4? 6. What's 1/2 to the 6th power? Well, that'd be 1 to the 6th over 2 to the 6th. What's 2 to the 6th? 64. Now plug in 1. What's 1 plus 4? 5. What's 1/2 to the 5th? Well, it'd be 1 over what? 32. Okay, plug in 0. What's 0 plus 4? 4. So that'd be 1 over what? 16. Plug in -1. What's -1 plus 4? 3. What's 1/2 to the 3rd? 1/8. And now plug in 2. -2. What's -2 plus 4? 2. What's 1/2 to the 2nd power? 1/4. Okay, so you can see, gosh, those are really, really tiny numbers. So I'm not even sure. I'm going to make my own graph for this one because switching those are going to be, like, they're so small. So I'm going to go 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. Okay, so now when we do the original one, we're going to take and we're going to flip-flop these. So I now have 1/4 -2, 1/8 -1, 1/16 0, 1 over 32 1, 1 over 64 2. So 1/4 -2. So you got 1/4 -2. Sorry. Oh, wait a minute. I'm looking at my. Did I graph that wrong? Because it should be over -2 up 1/4. Is that right? Is that graphed wrong? On my answer key? Oh, no. I'm looking at the wrong one. Never mind. I have it on the wrong side. We're good. Never mind. We're all good. Over 1/4. Over 1/4. Down 2. I see what I did. Okay, then, yeah, see, I stretched this out. That's probably a good idea. Let's do this. Let's make that 1/2. Let's make that 1. So let's make this 1/4. I see what I did. All right. So go over 1/4, down 2. Over 1/8, down 1. Over 1/16, down 0. Over 132. And so what's happening? It's getting closer in that direction. That one was hard because those numbers were really, really close together and small. All right, Jordan's not here. Ava Bays is here. Jordan. Ava. Okay. All right. Questions on that? All right, let's pass those in. We went a lot longer over that than I wanted to, but that's okay.
I got a bigger piece. Oh, you
Alrighty. So remember two things. Let's think about this first graph. So you guys have these on your guided notes. What kind of graph is f of x equals 4 to the x? Exponential, and more specifically an exponential what? Growth. Do you guys agree that that would be an exponential growth? Make table of values. -2, -1, 0, 1, 2. Now, guys, I could, to make life go a little faster, 4 raised to the x. Zoom 6. Look at my table. Oops, I'm way up there. I got to go way back. Trying to get back to the negative. Stop. Okay. So here at -2, I have 0.0625. At -1, I have 0.25. At 0, I have 1. At 1, I have 4. At 2, I have 16. So you could, or you could put them, do them in your head like we've been doing them, and we would get those same answers. So over -2, super close to that x-axis. Over -1, still kind of close. Over 0, up 1. Over 1, up 4. And over 2, way up there. So remember, we have an asymptote at the x-axis. There's your exponential growth. Remember, this is the inverse of 4 to the x. Because if I swoop, I would say log base 4 of y equals x. Switch your x and y, and you've got this. So to find or graph this one, I would take the x's and y's, and I'm going to switch them. Okay. Now, where's my asymptote on my log function? The y-axis. Very good. So I'm going to go over just a teeny bit, down 2, over a quarter, down 1, over 1, up 0, over 4, up 1, and so on. And remember, this one would come like this. These graphs have a couple important pieces of information. This one has a y-intercept at what number? At what number? Okay, at 0, 1. So this one has an x-intercept at what number? 1, 0. Remember, everything's flipped. It's inverse, so x and y are flip-flopped. This one has an asymptote at what? Well, it's at the x-axis. What's the equation of that x-axis? You guys know which axes does it cross? The equation of this line, it crosses which axis? Y at what number? 0. There's the equation of your asymptote. So what's the equation of your asymptote here? Okay, it would be at what? X equals 0, right here. Crosses the x-axis at 0. All right, if we're looking at the exponential function, so today we're going to talk about the blue graph. We're going to shift and change and move the blue graph, exponential functions. I have a horizontal asymptote. So what kind of shifts affect that asymptote? If I shift this graph left or right, does that change my asymptote? No. But if I shift it up or down, does that change my asymptote? Yeah. Okay, what if I reflect over the x-axis? Does that change my asymptote? No. What if I reflect over the y-axis? Does that change my asymptote? Okay, so just shifting up and down. Notice on your chart, these rules have not changed. They just look a little bit different for our exponential functions. They're thinking about having the parent function f of x equals 4 to the x power. That's an exponential growth. If I want to go left or right, notice it is raised with the power. So right 3 is raised up with that x, minus 3. Left 2 raised up with that x, plus 2. Notice if you want to go up or down, it's out back. It's just plus 5 to go up 5. It's just minus 1 to go down. Do you guys see the difference between what it looks like to go left and right versus up or down? Okay. Next one. Reflect over the y-axis. Well, what do we change if we reflect over y? You change x, all the x's. So you just come to x and make it negative. What do you do if you want to flip over the x-axis? Well, you make y negative. Y is the whole equation. So you put a negative out front of the whole equation. Negative 4x. You guys know if you put a negative out in front, it flips it over the x-axis. Okay? Now, our horizontal stretches and shrinks have not changed. They're still the hard ones. Horizontal. If you want to do a horizontal shrink by 1/2, remember that means you make the x's become 2x. So notice instead of 4 to the x, I have 4 to the 2x. If you want to do a horizontal stretch by 2, x's become 1/2 x. Notice they have x over 2. That's the same as 1/2 x. Either one would be the same. Vertical, you multiply the whole equation by 3 to do a stretch. Multiply the whole equation by 1/4 to do a shrink. Thoughts on that? Okay, so let's look at these first ones. Tonight's are all exponential. Describe the transformation, then graph each function. Okay? So, Caden, here's you have to pay attention to the original function. The original function was 3 to the x. So what changed over here?
Up 2.
It went up 2. So the only thing that changed was right there. It went up 2. So that's describe the transformation. Now, I'm going to be honest. I don't graph each function. I just graph my new one. Here's what I want you to graph. I want you to tell me where the y-intercept is. Okay, so where was the y-intercept on the red one? On the original function. Remember, the y-intercept, you could let x be 0. When you let x be 0, what's 3 to the 0? 1. Or it's the number that's multiplied out front. Well, we don't really have anything there, so there's an invisible what? 1. It's the starting value. Your starting value is 1. What happened to that 1? It went what? Up 2. So there's my new y-intercept. So that's one of the key points I want you to graph. I also want you to show me where the asymptote went. The asymptote was here. Where is it now? Well, it went what? Up 2. So it went up to where? There. So you dash that to show that it's an asymptote. And was this a growth or a decay? Why is it a growth? Because the base of my power is what? Greater than 1. Okay? So my line is going to come and go up. And that's all I'm going to expect. You don't have to make a table of values for this. Show me your starting value, your asymptote, and growth or decay. Starting value, asymptote, growth or decay. Can you guys handle that? Okay, let's try another one. Look at the original problem. Let's start by starting problem. Growth or decay and why? Why is it a decay? Okay, the base of my power is less than 1. Good. Now, there are 2 transformations on this one. 2 transformations on this one. What's the plus 1 up with the x going to make it do? Left 1. And then what's the minus 6 going to make it do? Down 6. Are you guys good with the transformations? Okay, let's start with the original y-intercept. Where's the original y-intercept on f of x? At what? 1. What happened to this y-intercept? It went what? Which way did it go? Left 1 and down 1, 2, 3, 4, 5, 6. My asymptote was at the x-axis. It went down what? Now, this is a decay, so it's going to go in this direction because it is a decay. Yeah, could you type this in your calculator and look at it closer if you don't believe me? Yes. Questions there? All right. Look at another one. Same thing. Describe the transformations, then graph. Let's look at the first one. What type of a function is this? Think about the base. What's the base? What's the value of e? What is it? 2.7? Okay, remember, e is 2.71. So, is it a growth or decay? All right, so this is a growth. What's my starting y-intercept? 1. Okay, so we know it's a growth. We know it has a y-intercept at 1. We know it has an asymptote at the x-axis. Now let's talk about this one. What has happened to this graph? What's the plus 3 going to make it do? Left 3, and then what? Left 3 and up 2. Okay, so my point went left 1, 2, 3, and up 2. How about my asymptote? It was at the x-axis. It shifted what? It's a growth, so it's going to go up to the right. What do you guys think? Bad, is it? Okay, this one you have to be careful on. You have to be careful on this one. Okay, look at the original problem. Is that a growth or decay when it has a negative x? It's a decay. Remember, if it's a negative x, it's a decay. If you don't believe me, you could always do e to the negative x, graph it. Where's your y-intercept? 1. Okay, so it is a decay at 1. Now, which way is it shifting? Yeah, this is the same. The only thing that changed is what? Down 5. So this one shifted down 5. So my point shifted down 1, 2. Try this again. My point shifted down 1, 2, 3, 4, 5. And my asymptote shifted down what? 5. And we said this is what? Decay. So it's going to go like that. Thoughts? Okay. Is this our last one? Bonus. All right. Let's talk about the first one. Growth or decay? Decay. Where's your y-intercept? 1. Where's your asymptote? X-axis. Now, be careful with this one. What's happening? Horizontal what? Shrink by what? Horizontal shrink by 1/2. How'd you get that, Drew?
Because it's with X up there, and it's gotta drop like low to horizontal.
Okay, it was a 2 with the X. So that means with its X, with the X, it's horizontal. Okay, we have to reciprocate it. It'd be 1/2. So since it's 1/2, it'd be a horizontal shrink. What else do we have up there with that 2X? A negative. What happens if you have a negative with the X? It reflects about the what? It reflects about the y-axis. Woo. Okay. Okay, so let's think about this once. I am going to come in and draw my original function. This is my original function, okay? I'm going to reflect about the y-axis first. If I reflect about the y-axis, it's going to come and do what? I missed that a little bit, but it's going to come and do that. Do you see that? Yeah. And now, if you do a horizontal shrink, think about taking the green graph and pushing it together. What's going to happen to the steepness of that? It's going to get what? Steeper. Do you guys see that? So this is your final graph. Does it still go through the point 1, 0, 0, 1? Does it still have an asymptote at the x-axis? Yeah, that one was tough. Use your calculator if you need to help you a little bit. It's a lot of graphing tonight. The first 4 are multiple choice.
He wasn't Laura. I color. Do you understand what's happening with the book? Yeah. I'm kind of lost. I like the green.
Oh, you did that, Bob.
You look much better. I like this.